Hi everyone. Today we're presenting the new observability feature recently launched with CWCloud. So what we can see here is that we have a monitor menu. The monitors will actually be used as health checks that we can easily configure right here. What exactly is a health check? It's a specific endpoint that we'll invoke at regular intervals to check its response. For example, here we'll check that the HTTP code starts with 2 and 0. So if the code is different from 200, 201, or 202, the monitor will be in a failure state. Otherwise, it'll be in a healthy state. We can also add specific checks. For example, asserting that the response's body must contain this field's value. We can set up authentication or add custom headers. For now, we'll focus on HTTP checks. We'll add TCP checks later. We can also see that we have different HTTP methods. With put and post, we can set up a requests body. So what we're going to do is a very simple check. We will use the health endpoint of CWCloud. We can see that it's responding with an HTTP code 200 and status OK. Here I'm adding a check on the response's body. So the endpoint's response has to return a code beginning with 2 and 0 and includes status OK in its body. Now let's copy this URL and paste it here. Let's name it TN Cloud Health. And here I will put a grouping key. Family is a grouping key useful if we need to create multiple monitors that we want to display in the same dashboards with Grafana. Let's demonstrate this later. So here we got our new monitor and we can see that it has successfully run. Now we can observe that we have also a metrics endpoint which is providing a list of Prometheus metrics. And we can see that our monitor appears on the list with these gauges metrics. We also can see that we have different labels including the various fields we configured in the monitor. Those will help us to filter and aggregate the values with Grafana. The values 1 means that everything's fine. Here's also the duration. Now I am going to access and explore Grafana. Here we can see Grafana and our main data source is Quickwit. Quickwit is a very powerful indexing and search engine that competes with Elasticsearch. We choose to use it even for storing our Prometheus metrics, and we're using vector in order to transform those metrics into indexable documents. We made this choice in order to reduce the cost thanks to the fact that Quickwit is using object storage. This allows us to keep the metrics with very large period retentions. And for our monitoring needs, it's sufficient in terms of aggregations capabilities, even if it's not a real TSDB. I wrote a blog post that will appear on this screen with a QR code you can scan. You'll also find the link in the video description. It provides explanations on how we transformed Prometheus metrics into indexable documents using vector and Quickwit. That being said, here we can see that we can find our metrics which are coming from the Prometheus endpoint vector is scraping. Here it's a duration gauge. The labels has been stored as tags and we can use it to filter the results. Here I can filter on the family tag and also on the kind tag in order to see only the result of the monitor's execution. So I'll add also a filter on the family tag. As I was saying, it allows us to filter easily all the metrics grouped by the family tag. I can also use other filters, but it's more convenient that way. Now we got all the metrics values, which illustrates that the endpoint is invoked periodically. So it'll allows us to make some dashboards or status pages with Grafana. I enjoy using traffic light visualizations for that. We can see that we have already set up some dashboard for our various customers. So here I'm going to copy this panel, for example, and then I'm going to create a new dashboard to better visualize our data. And use our Quickwit index, which contains the Prometheus metrics. I already copied a panel. I just have to paste and update it. Here we can see the Lucene query. Here I'll just change the family with TNCloud. The query is still relevant. And now we can see our traffic light. The light's green. How does it work? We set up an average aggregation on the gauge values and set up the thresholds. It'll appear as green if the average is greater or equals than 1 or red otherwise. So now I'm saving this dashboard and calling it TNCloud. Et voilà. Now let's have fun and breaks the monitor. Here I'm going to change the body check in order to make it fail. There you go. Let's save and return to the Explorer. So typically, if I play again the request tags.king, result and tags.family, cloud tn, we can notice that we got the gauge have dropped to 0, which is indicating an issue. Now if I go back to the dashboard we just created, we can see the light has now turned red. This means a critical alert that requires immediate attention. So that's how we're able to create all our monitoring dashboards and alerts for all our customers. Afterward, we can create public status pages, for example, status.comwork.io. This status page is publicly accessible on the internet. It can replace all the existing status pages SaaS applications available on the market. More features are coming. Moreover, CWCloud is also compliant with the OpenTelemetry standard. In this section, I demonstrated how to scrape metrics from this Prometheus HTTP endpoint. However, we can also configure an OpenTelemetry endpoint where CWCloud will send all the metrics, logs, and traces through OTLP gRPC. Here you go, and I hope you'll have a nice day. Thank you for watching the video.